Hi everyone. Introducing MRO360. MRO360 is an agentic AI/EM solution designed to help with inventory modeling and improve demand planning for spare parts. Let's take a look at some of the individual functionalities offered by our product. The first feature we want to highlight is spare parts search. Whether you are an inventory controller or a plant manager, it is important to have a cumulative overview of all spare parts distributed across multiple sites or locations. Having a consolidated view of all spare parts is crucial. That's where our spare parts search functionality becomes very useful. Let's see how this works. First, the user needs to go here and simply select the plant. Once the plant is selected, all relevant spare parts available at that specific plant will be listed here. If a user is searching for a particular spare part, there are two options available. The first option is AI search, and the second is smart search. Let's discuss the AI search feature, search. For example, if you are a technician or engineer in the field looking for specific information about a spare part, such as the available stock in inventory, the manufacturer, or any technical specification, our AI search allows users to simply type in a query or state what they are looking for. Our system will provide the result and even generate reports that could otherwise take hours to create manually. The second option is to use Smart Search, where users can search for a part based on the manufacturer or category. For example, if we type the manufacturer's name, it will filter all the relevant spare parts produced by that specific manufacturer. If someone is looking for additional details, such as minimum and maximum levels or safety stock levels for that spare part, they can set those values here. They can also view other relevant information, such as available stock, restricted stock, all on the same page. Let's move on to the next functionality, which is equipment criticality analysis. As you know, calculating equipment criticality manually is a very tedious process. It requires a lot of data points, such as mean time between failure, mean time between repair, information about the upstream and downstream systems, the equipment's role in the plant, and which spare parts are installed in the equipment. All of this relevant information is necessary for calculating equipment criticality. With the help of our Agent IQ AI system, this process can be completed in a matter of days, and with much higher accuracy. Let's see how it works in practice. First, the user simply goes here and selects the plant. Once the plant is selected, they choose the criticality scale that the company uses for calculation. This could be a 1 to 5 or a 1 to 10 scale. Lastly, they select the AI criticality model. These are industry standard models used to calculate equipment criticality. However, if a user prefers, they can provide their own customized model for this calculation. Let's say we proceed with the production loss-based model and run the AI model. Now, behind the scenes, our agent is currently fetching all relevant information from your ERP or CMS system, which will be used to calculate the criticality for equipment. Additionally, it retrieves any maintenance notes or maintenance history written by technicians or engineers during equipment repairs in the field. This information is extremely valuable for the AI. However, it is often overlooked when calculating criticality for equipment manually or when using other software. As shown below, our system has calculated the criticality for the equipment. You can see the AI rating here, as well as the current user rating specified here. If a user wants to know the complete explanation or summary of why the AI assigned this rating, they can simply click here. The complete AI summary of the current criticality rating will be displayed, along with the individual components that contribute to the criticality. Just like equipment criticality analysis, our system also performs spare part criticality analysis. It works in a similar way. The system fetches relevant information from the ERP system. Of course, the parameters used here are different. The focus is more on which critical equipment is being used, what the equipment criticality is, and how much the spare part has been consumed. We consider more than 20 parameters to calculate the criticality for spare parts. The process is similar to equipment criticality. The user will go here, first select the plant, then select the scale, and then select the AI criticality model. Users can also provide their own customized model for calculating spare part criticality, and simply click on Run AI Models. Just like before, the system will provide the AI rating, indicating what the criticality of the spare part in question should be. If a user wants, they can view a complete AI analysis explaining why this criticality rating was given. If they wish to go deeper, they can also view the individual component breakdown. Before we go into the reorder point review, let us first review the demand forecasting section, and then we'll return to the previous topic. As you know, having an accurate demand forecasting process for spare parts is extremely valuable for any company. Not only does it help prevent excess inventory, but it also helps avoid stockouts in the plant. That is why a robust demand forecasting system is so important. Our Agenti system is a multivariate solution. It not only analyzes the consumption pattern of the spare part in question, but also considers equipment operational hours, maintenance history, and any root cause analysis related to the equipment. It collects all this relevant data to enhance the demand forecasting. We offer multiple AI models to handle demand forecasting, including situations where demand is intermittent or very sparse. The system is able to accurately calculate the demand forecast in these cases. Our system automatically suggests the best AI model for calculating the demand. Users can simply click on Run Selected Model to proceed. Alternatively, our system can periodically calculate the demand forecast for spare parts on behalf of the user. A user can go to this section to see the demand forecast for each spare part. For example, our system indicates that in November, the total expected demand for this particular spare part will be 100 units. If we scroll down, we can see the distribution between planned and unplanned demand for that specific spare part. This information is very valuable because it helps users focus on the spare parts most frequently used for unplanned activities, ensuring those spare parts are always in stock and preventing stockouts. The next module we want to discuss is the Work Order Planner. Before we explain how it works, let's consider a scenario. Imagine you are part of the maintenance team, and every day you handle hundreds of maintenance orders that need to be fulfilled. Now, over a period of 30 or 45 days, you may be dealing with thousands of maintenance orders. Each order requires a particular spare part to fulfill the demand. However, keeping track of all these spare parts manually is nearly impossible, and when vendor reliability is also a concern, it becomes almost impossible. That's why we developed the Work Order Panel piece. It acts as an early warning system, a proactive tool that lets users know which maintenance orders need immediate attention. It also highlights the latest date for the procurement of critical spare parts and identifies the vendor who can deliver the material on time. By using this system, users can ensure that all priority or critical maintenance orders are fulfilled on schedule without last-minute firefighting to secure materials through expediting or sourcing from other plants. If users encounter difficulty procuring a specific material, our system suggests recommended actions to assist with the procurement process. The first option is to place an emergency purchase order. Our system will automatically fill in all the relevant information needed for a PR request, and after user approval, it will be sent back to the ERP system for processing. The second AI-driven action is a stock transfer request. Users can request a stock transfer from another plant where there is a surplus of the required material. Our system also recommends the quantity that should be transferred from one plant to another, ensuring materials are procured on time. Additionally, our system can send expedition emails to vendors for faster delivery, or suggest alternate vendors with lower lead times to help meet urgent requirements. Now, coming back to the reorder point review. As you know, having an accurate reorder point is crucial for inventory modeling. If the reorder point is not precise, you could end up with excess inventory that ties up working capital, and conversely, if the reorder point is too low, you risk stockouts of critical spare parts when they are needed most. Our system addresses this by using demand forecasting data and consumption patterns to calculate minimum, maximum, and safety stock levels for each spare part. It also determines the correct reorder points for the next 6 months, or up to a year if needed. Since our system is continuously integrated with the ERP system, it can send these details directly to the ERP and create purchase requisitions at the specified times. Below, you can also see the distribution of the recommended reorder quantity and reorder date for each spare part. This approach helps you optimize your inventory, ensuring you have neither too little nor too much of any given spare part. The next functionality we want to discuss is Obsolete Check. Now, imagine a scenario. You are a procurement specialist trying to secure the right material on time. However, when we try to place an order, we discover that this material has been discontinued by the manufacturer. At this point, we may not know the new part number, or if the manufacturer has provided an alternative for procurement. What our system can do is periodically check your inventory for parts that have been discontinued by the manufacturer and provide you with the alternate part number that has been issued for that specific spare part. Let's see how this works. First, the user will go here, select the plant, and then choose the run frequency. The analysis can be run on a weekly, bi-weekly, or monthly basis. After that, simply run the analysis. Now, our system is accessing vendor and manufacturer portals, searching for parts that have been discontinued. Below, you can see the system is suggesting that the first part has been discontinued by the manufacturer. Let's look into the details. This part has been discontinued, but our system suggests that a new part number has been issued by the manufacturer to replace the existing part, along with key improvements. If the user wants to find alternate vendors who can supply this specific part, they can view this information here. The system will also display the lead time and price for that particular spare part. Additionally, our system can inform users about which vendors have a limited stock of the current spare part, in case they want to proceed with that option. The next functionality we want to discuss is stock velocity. Having relevant information on which spare parts are fast-moving, slow-moving, or non-moving in your inventory is extremely valuable. For fast-moving spare parts, you may want to stock more and maintain a higher safety stock level. However, for spare parts that are non-moving, or have not moved at all in the last 2 or 3 years and are not critical, these are essentially junk inventory, simply tying up your working capital. Our system can generate a comprehensive report, identifying non-moving and non-critical spare parts. You can then decide whether to consume them, remove them, or transfer them to another plant, freeing up working capital. In summary, multiple agents work together simultaneously to help you better optimize your inventory and improve demand planning for your plant. Thank you.